Okay, the second question here is very simple, but of different style. So let's look at a situation where you have a question like this in an exam condition, and we are asked to find what? To calculate the power rating. We need to calculate the power rating. Where's my chalk? We need to calculate the power rating. It's not just, which is also heat. Yes, that's another way to put it. Power rating, heat generated by certain thing. Alright? So calculate the power rating of an immersion heater, what you call boiler, electric heater, and so on and so forth, right? Used for 10 minutes, look at it, for 10 minutes to increase the temperature of 10 kilograms of water by 15 Kelvin. Hence, specific heat capacity of water is given as 4,200 joules per kilograms per Kelvin. Alright? So what do we do? Option A, 1050 watts. Option B, 16800 watts. And option C, 18060 watts. And option D, 2160 watts. How do we now know which of the options is correct? By solving. It's only by solving this and arriving at an answer that corresponds to any of these. That's all. Okay, let's go. Let's do something. Solution. Alright, we have solution here. So let's see. We bring out our data first of all, as usual, right? As usual, we write down our data. We're calculating power rating. That means P is unknown. The power rating, the power is unknown. So we're going to look for this. Okay? It's used, that heater, immersion heater is used for 10 minutes. So time here is 10 minutes. Alright? And this is equivalent to what? 10 times 60. That's 600. This is equivalent to 600 seconds. Okay, let's put it this way. All right, so to increase the temperature of 10 kilograms of water, mass is 10 kilograms. 10 kilograms, okay? We have mass 10 kg. Good. My chalk, okay? Then temperature, T. Yes, we're going to use capital T here because we use small t for time. Temperature is 15 Kelvin, right? Good. So we're going to work with this. Look at the data. Just look at the data. We are looking for power. We're looking for what is it called? Power. Time is given. Mass is given. Temperature of the water is given, and so on and so forth. Then finally, the specific heat capacity of water is given. That is CW is given as 4,200 joules per kilograms per Kelvin. Good. So that's it. Now, what's the connection here? Very simple. You know that heat under normal circumstance, the formula for calculating heat, which has been replaced with the word power rating. So under normal circumstances, the power rating or heat can be calculated as H is equal to mc theta, right? But this time, H has taken the place of power rating, so we are going to use P this time. Means that P, which is PT, is equal to, or rather, let me do it this way for clarity purpose. For clarity purpose, we can use this. IVT is equal to MC theta, okay? Where IV represents the power, okay? If we see that, say that where IV implies P, power, okay? All right? That's what it means. IV means power. Current times voltage means power. So anywhere we see that, we replace with P, or we substitute with P. So if we have IVT is equal to MC theta. For IV here we have P, okay, and then we return our T, which is time, and then MC theta. Of course, we need to change this T to theta because we're talking about temperature, but in its absolute nature, right? Okay? So that's if we're looking for power. P now becomes, we transpose P to become the subject, and we have MC theta all over time. Good. Good. The next is for us to substitute, and it's done. Let's just substitute and see what we are going to arrive at. So we have P is given as for M. Where is our M? 10 grams. 10 times C is 4,200. 4,200. Then theta is just 15K, 15 Kelvin, right? We have 15 Kelvin. All over time is 600 seconds. 10 times 60, 600 seconds. So 600 seconds. So let's see. This is 600 seconds. Okay. So what do you think? What do you think is the value now? So P is equal to dash. I want you to find this. It's measured in watts. P is measured in watts. So what do you do? What do you do now? Simply press a calculator. 10 times 4,200 times 15, all right? All over 600. Whatever it gives you, put it here in the comment section, and that should be the answer. Then check if your answer corresponds with any of these options given, all right? That's what it means. I want to believe that the steps are very clear and self-explanatory. But if you think you're having issues, you're having challenges solving this, put it in the comment section. Give me some likes, okay? Subscribe. Come on, share with your students, fellow students, or with your student if you're a teacher, and so on and so forth. Give me some likes. Comment. I want to read your comments. Right? Yes, I want to read and see whether this thing is making any sense, doesn't make any sense. Just put it in the comment section, okay? I'm signing out now, okay?